Miguel Toribio-Mateas is the chairman of the British Association of Applied Nutrition and Nutritional Therapy. His main focus is on anti-aging, healthy aging. So he's going to ensure that none of us age anymore past tonight, right? Give us all we need to know in order to do that. He has a ton of credentials that he'll show you on his presentation here, but everybody give a warm welcome to Miguel.
Can we take these lights off, like at the front? All right. Oh, that's kind of cozy now. We just need a candle now and a few joysticks. Hi, everyone. My name is Miguel. I'm actually Spanish, but I've lived in the UK for 20 years. I'm kind of a hybrid now because I'm quite Anglophile. So I am actually really love living in England. So I've got a bit of a mix of an accent. Sometimes it sounds very Spanish, sometimes very British. If you don't understand me, stop me at any time, and I'm happy stopping and going through whatever you need to know. So that's a little bit more about me. I'm not going to bore you about the things that I've done or what I'm doing. Main focus is nutrition. I chair BANT, which is the British Association for Applied Nutrition and Nutritional Therapy, with 2,200 members in the UK. Nutritional therapists in the UK are a bit like a hybrid of a clinical nutritionist and a functional medicine practitioner. So names are kind of different in different continents. That's kind of what it means. And the reason why I'm here, I met Susan actually on the tube, on the underground in London. We were both at a functional medicine conference, and I think we were both late because the tube was actually stopping between two stops, and we just got talking, and it just turned out that we were there at the same conference, and we really hit it off. So we kept in touch, and I invited Susan to talk at a conference last year, and she returned the favor. Last year or earlier this year? Earlier this year. No, last year. So yeah, so that's the story, and it turns out that Susan had been, within 2 minutes of talking to each other, she told me that she had been studying with the A4M, so doing the anti-aging or metabolic medicine or whatever it's called now. They are changing names apparently, and I said I'm doing that as well. So there was another reason for us to kind of like get talking, and that's one of the things that I focus on. So the healthy aging, particularly on the brain side or the central nervous system side. And today I'm actually going to be taking you around the body a little bit. So it's not going to be completely brain focused. So I probably should have named it something else, but there will be a lot of brain, but a lot of kind of like whole system picture as opposed to just brain, and a few little theories that I use in my practice that are to do with energy as well, and how we use energy and why we get kind of why we age as a result of how we use energy. And energy, you can take it into account as ATP or kind of physical energy, but also kind of subtle energy and things that you cannot touch but are there. Why are we alive? That kind of energy. So why do we age? Do we age just as a result of a physical kind of a program that's almost like an operating system that's inside us, like a computer? Is it accidental? Is it, oh, hang on, this works as well. Is it wear and tear? There's a lot of theories about wear and tear, and kind of we just accumulate a lot of damage as we go along, a bit like a car or like a dress or something, and it ends up looking a bit, you know, torn. Is it pre-programmed in our genes? Do we have genes for longevity and genes for aging? Do we have such things? How do they compare to the genes that we had 15,000 years ago when we were running from, I don't know, animals and wearing skins and all that kind of thing, and had hunter-gathering and all this kind of thing? Are they the same genes, and were we programmed to age at that time? So one of the theories that we look at in aging is accumulation of damage, and accumulation of damage that actually damages the DNA. And a lot of what I'm going to be talking about today is accumulation of excess intake of calories, for example. That's one of the main sources of aging that we're exposed to in the society that we live in. There are a couple of pathways that are really interesting in aging. One of them is called the MTOR Pathway, that I'm going to be dedicating some time to as part of the presentation. And also what I'm going to be looking at is the combination of internal and external sources of aging. So we've got this balance between sources of aging that come from our own metabolism, like the generation of energy in the mitochondria, and external sources like exposure to sunlight and oxygen, for example. So there are definitely some links between the mitochondria and DNA damage. So mitochondrial activity, everybody familiar with the mitochondria? Tiny little fellas inside cells that make energy. So we need them. We need those fellas to be doing what they do, and we need that activity inside those cells that is going to generate free radicals. So in burning calories, in burning nutrients that go into those mitochondria, there's going to be heat generated in the body. It's going to be heat generated inside the cells, and that heat translates into what we know about as free radicals. So those free radicals, if they are excessive, if they tip over towards the excessive point that we're going to be looking at, can actually damage the mitochondria themselves, and they can damage cell membranes and so on. So there will be, there's always going to be this spectrum. It's a bit like the good and the bad, and the yin and the yang. And there's going to be a spectrum between damage and regeneration. And antioxidants will help us with regeneration. Caloric restriction will help us with regeneration. And some small molecules that enhance DNA repair will help us with regeneration, or with integrity of DNA, with DNA stability or genomic stability. And those will be covered towards the latter part of the presentation. And I'm going to focus particularly on plant pigments, on phytonutrients. So, yeah. So, again, I was talking about how we definitely have some genes that we talk about in general as longevity genes. Like people talk about the transcription factors like the FOXO gene, for example, as longevity genes. I'm not actually sure that we've got a longevity program. I think it's just almost a coincidence that we can actually live this much because we were not actually pre-programmed to live this much. If you think about when we started being the humans that we look as today, 15,000 years ago, 20,000 years ago, nature didn't actually have any idea that we needed to live until 80 or 90. The moment that we had a baby, that was it. We were dispensable. So we didn't actually need to have this program that allowed us to live until we were 100, and we were happy 100-year-old fellas running around and picking up berries and so on. So that's actually not pre-programmed. That's the theory that's actually coming up quite strongly in research. And in fact, I'm just going to show you something, okay? And what we actually are dealing with is this spectrum between cell survival and cell death. And that's going to be tipped over in one direction or the other direction by the production of different molecules, many of them related to these free radicals that are produced by the mitochondria. So we all have certain abilities to fight those free radicals innately. So we'll all have specific genes like the glutathione genes. We can either have one or two of the glutathione genes or not have either of the two. And the superoxide dismutase genes as well. We can either have a more favorable variation or a less favorable variation that is going to allow us to fight these free radicals better or worse. So all of the references for all the pictures that I'm showing you are actually in the notes of the PowerPoints. So I'll share this with Susan later, and they will appear in the PDF with links that you can click on to get the articles. So so basically, there's this main theory that talks about accumulation of molecular damage as one of the reasons for aging, and the main reason that that we will end up going into a malfunctioning state or an aging state is by loss of homeostasis or loss of balance. As I was saying about, talking about before, this happens mainly because of oxidation. So we've got this oxidation that's the result of the work of the mitochondria making energy in the body. We can see some of the names that I've been talking about already there. So the superoxide anion and the superoxide dismutase, as well as glutathione coming up in there. So we're always going to be exposed to this kind of a free radical generation and antioxidant fighting those free radicals. So here we have the mitochondria. The mitochondria, again, as I was saying, are going to be the powerhouses of energy in the body. They're going to be generating this thing called ATP, which is the energy currency in the body. And the more we feed into the mitochondria, the more calories we actually feed into the mitochondria, the more free radical formation we're going to be exposed to. So this is one of the key aspects. And again, I'm kind of like going through the theories in the beginning. We're going to get a little bit more practical in a second. But just to get an idea that the mitochondria, these tiny little organelles inside the cells, are going to be one of the main sources of free radical formations, and free radicals are going to be one of the main sources of aging, particularly brain aging. So I'm trying to just get my thread together. As a result of this exposure to high calorie intake or excess of hormones, for example, that can accelerate that process as well, we're going to get what is called an oxidative burst, so an excess in oxidation that is related normally with an excess in inflammation as well, particularly at cellular level, so in the cell membranes. And that's coupled with insulin resistance. So all of those things that affect brain function, oxidative burst, inflammation, low cellular function, and insulin resistance. And at the same time, as oxidative stress, inflammation, and exposure to high calories continues and is chronic, health actually diminishes. So I use this graph actually in an environment that's different to nutrition, which is coaching on this thing called HeartMath, which I'm not sure that you know about, or I'm sure that many of you will know about. So HeartMath is the Institute of HeartMath is actually based in California, not far from here, and they've been going for quite some time, and they are about self-regulation. So self-regulation of the two sides of the central nervous system, the autonomic nervous system. So the sympathetic nervous system and the parasympathetic nervous system. The sympathetic nervous system is the kind of like the upper, get up and go, fight or flight kind of part of the central nervous system, and the parasympathetic nervous system is the balancer, the regenerative part of the central nervous system. Now, it's quite interesting that this actually comes from a book called Psychoneuroimmunology, published in 1997 by a guy called Watkins. And it's part of the materials that you get when you train with HeartMath to be a coach. And some of the new theories on aging and exposure, chronic exposure to excessive calories, that is kind of like one of the common themes of what we see in our practices as practitioners at the moment. It's almost like a carbon copy of this model, and there are two completely different people publishing in completely different areas. They probably haven't even met, but it's quite interesting that we go through a period of maximum efficiency in systems performance or in organ performance, and then you start by pushing the performance of that organ, and that can be the brain, or it can be the liver, it can be the heart, it can be the skin, whatever it is. It could be the whole body. You go into this hyper-reactive stage, which is a lot of what we see before we actually go into a decline. And that's when you start experiencing all sorts of diseases, whatever label you give them. So I'm not actually going to talk about specific labels. I'm going to talk more about the underlying balances of those diseases. If you have a look at another model from the same book, this is about anabolic and catabolic. So you can start talking about or relating this with hormonal function, for example, and you look at, I was talking to Susan about hormones later and how functional medicine guys are looking at things like thyroid function in relation to blood sugar, and those are two common themes in functional medicine that perhaps non-functional practitioners kind of like ignore a little bit. And in a functional medicine kind of practice, you see this a lot, that you go into an anabolic or an excessive kind of response. If you look at chronic fatigue, for example, of people suffering from extreme fatigue, you can see that they have got there because they have been overstretched or stressed for a long period of time, and then they find themselves going into a bit of a decline. So that go into that period of intended performance that doesn't quite work, and actually they go into an exhaustion kind of pattern, ill health, and P is the point of no return. That's the point that if somebody comes to see me at that point in my practice, I'm going to take 2 years to make them feel better, as opposed to if they came to see me just around there, that it could be months or it could be weeks. So that's the kind of pattern. And if you look at how this actually maps with one of the most cutting-edge theories on programmed aging. This is by a guy called Mikhail Blagoskone. He's a Russian guy who works at the Roswell Center, Roswell Park Cancer Center in Buffalo. He's written about 220 articles about this age programming based on nutrient-sensing pathways, and particularly a pathway called MTOR, which is the mammalian target of rapamycin. So I'm going to talk about MTOR in more detail in a second, but it's key to what we're talking about today, and I hope that we've gone through the houses a little bit. We're getting kind of making a little bit more sense as we go along. But what I wanted to convey with the last few slides is the fact that there's this, in aging, this stage of functioning, the normal function that is coupled with the normal program of development. That's from birth to reproductive age. That's the kind of like normal aging program that we have, the operating system that we have. As I was saying before, once we have a baby, nature doesn't really care anymore. We may attach romantic ideas as to why they should care or not, or have different belief systems, but the reality is that in biology terms, once you've reproduced, then you're dispensable. So at that point, you could easily just die, and that's it. Your physical life is finished. But instead, we go into this either slow or rapid quasi-program of hyperfunction that can be coupled with different imbalances. So that's when you're not feeling quite right, but you're not feeling quite wrong. And as you go through your years, you may be like that for a long, long time and not develop any label diseases. You may just not feel quite right for a long, long time. Or you may go into a rapid decline that actually leads eventually to malfunction and death. And that normally follows a timeline that, that maps with diseases like degenerative diseases. When we're talking about central nervous system diseases, we're talking about Alzheimer's and Parkinson's and ALS and all of these kind of things. But sometimes they don't actually get the label because we don't get the diagnosis, but we're still progressing. You don't get Alzheimer's one day while you're walking down the street and you get it, like you get hit by a bus. You got it because you got it 10 years before or 20 years before and it started crawling in, and suddenly you got it diagnosed 20 years later. So that's the kind of model in a simplified way, which is why I like it. And that's the same model, but with MTOR at its center there. So MTOR, as I was saying to you before, is, it stands for mammalian target of rapamycin. Rapamycin is an immune inhibitor, and originally developed as a drug for, I believe, antifungal properties to kill things like fungal nails and things like that. I like to think of MTOR as, in fact, I think I've got another slide on MTOR in a second. I'm going to just skip a couple of slides. I'll come back to those in a second. So there's MTOR there in mammals. So TOR actually applies to yeast, worms, flies, all sorts of different organisms. But in mammals, actually, it has specific functions that I like to think about. They compare with a weather station, picking up signals from the environment. So you've got a weather station that picks up wind and humidity and all these kind of things going on around it. And MTOR actually picks up signals from nutrients that are circulating in the bloodstream. So it's actually picking up whether there is glucose in the bloodstream, whether there is insulin, whether there is insulin growth factors or insulin-like growth factors, whether there are amino acids floating about. So it's picking up all that information, and actually it's there for a reason. And again, this is one of the original pathways that was, if you were going to think about any programs that were given to us as operating systems, this would be one of the pieces, key pieces of the operating system. When we were running around hunting animals and gathering berries, this was the warrantor that if we had 3 or 4 days without food, we could actually survive, because its job is to be ultra sensitive to all nutrients floating about in the bloodstream, and actually sending messages. It's almost like going into a savings account kind of mode. So it picks up, it gets maximum energy from little nutrients. So if you're going to have a rainy day coming up, then you can actually go through that period without having to eat. So, so that's its job. And if I go back to another couple of slides, when we see this program of hyperfunction that we were talking about before, we go from a normal growth program into a hyperfunction and quasi program. So that's not really planned, but it just happens because it's a continuation of what we know. And we live so much longer that we just continue with that. And that's when you start getting cells that go a bit funny because they were not supposed to be living that long, and you go into cancers and all these kind of things. So if you just go into PubMed and enter MTOR, there are probably the best part of 2 million articles on this little pathway, which is related to, if we go into that slide in there, it's actually, its job is cell growth. So it's to make sure that growth continues to happen in cells even when there is scarcity. So it allows for energy to be picked up even when you have very few nutrients coming in. And it also has a job in guaranteeing transcription factors like the FOXO gene, for example. So it's related to longevity. It's related to longevity, particularly from the point of view that if you have scarcity in nutrients, you live longer than if you've got excess in nutrients. So that's why caloric restriction actually works, because it inhibits MTOR. It also has a big job with protein synthesis, autophagy as well, sending signals to cells to let them know that they need to auto-digest because they've gone faulty or something has gone wrong. And it also has a job in ensuring that cell proliferation actually takes place normally. Now, if you look at all of the things that actually enhance MTOR, mitochondrial signals, so again, energy, we've been talking about what happens in mitochondria. The generation of energy actually also generates free radicals. So that's a signal that the mitochondria are sending to the MTOR kind of like nutrient sensing center. Amino acids, glucose, and other nutrients, growth factors like growth hormone, for example, but also stress. And I'll talk about stress as well. So again, I was saying that I sent the title of my talk to Susan, and I said nutraceuticals and brain, but I'm actually kind of like mixing in a few more things in there as well. So I'll talk about stress later. But stress basically, could anybody tell me why stress would have an impact on MTOR? Cortisol, yeah. Yeah, so cortisol, which will release sugar from your muscle and liver as glycogen. So that will actually be the equivalent of taking in glucose. So that has the same effect. So again, if you want to live longer, again, it's common sense. If you want to live longer, try not to be stressed. So that's a good piece of advice, if you can manage not to be stressed. So, and it's related. I'm not going to go into a whole kind of molecular biology lecture because it's not my bag, but I just think it's really interesting that that's located in the middle of a whole lot of metabolic pathways that are related with cancer, that are related with longevity. So, sorry, I'm just blocking the view in there. So it's actually very interesting location right in the middle of all of those pathways in there. So what I wanted to convey again with the last few slides is the fact that we have an initial program of development that guarantees that we grow to an age that we can reproduce. And that actually takes us, if we enhance the nutrient sensing pathways like the MTOR signaling pathway, we can go into a hyperfunctioning state that leads us to loss of homeostasis and eventually death or system failure. So again, a lot of the factors that affect MTOR as a contributor to aging and diseases of aging. And if we think that MTOR activity may actually lead us to age more prematurely or to lose homeostasis in different systems that are key to aging successfully, like the central nervous system, for example, reducing MTOR or TOR signaling, depending whether you're a human or a mammal or you're a yeast or a fly. So that's a nice chart in there comparing the different effects in different species. And we can see that dietary restriction is one of the key interventions to diminish or to inhibit the activity of MTOR. to enhance autophagy and possibly to enhance longevity as well. So now, somebody said inflammation before. There is a correlation between MTOR activation, and we were talking about this kind of like seesaw of activity. I need to come this way. Yeah. So we were talking about this seesaw of activity between oxidation and antioxidation, and that is correlated with MTOR activation as well. So the more MTOR is activated and the more active that nutrient sensing pathway is in the body, the more glucose metabolism is going to be enhanced, the more mitochondrial and lipid biogenesis there's going to be, the more proliferation, the more amino acids are going to be produced, the more ATP. So there's going to be more abundance of those resources that are actually pushing towards an acceleration of inflammation and aging. And again, we were talking about different sources of oxidative stress. So here we've got a good indication of where they may come from. So we've got DNA oxidation coming from mitochondrial function, possibly exogenous. We may have, again, we talked about UV radiation, EMF can actually have the same kind of effect in the body. These effects can actually be measured via specific markers in urine, for example, like the 8-OHDG is a marker that can be easily measured in organic acid testing. And we've been talking about molecular damage as well that can be enhanced by MTOR activity. So again, we were talking about how this is correlated with most typical diseases of aging, like cardiovascular disease, fat gain, even with premenopause and Alzheimer's disease. So a lot of what we see in the society that we live in and the modern lifestyle that we've got is coupled with an excess of abundance in resources and an excess of calorie intake, for example, that can have an impact on increase of fatty acid production, alteration in adipokines, so inflammatory markers that come from fat cells, increased oxidative stress. All of these aspects are actually going to have an impact on aging. And obesity, even though we may not see each other, ourselves as obese, that central abdominal fat is going to be generating a number of different hormones that are going to contribute to DNA damage and increase reactive oxygen species production. So I've got a couple more on inflammation. I'm actually going to jump right into, okay, so more towards brain than we've been seeing before. This is from Frontiers in Neuroscience, and it's talking about the same kind of thing but applied to the brain. So it's actually looking at chronic overnutrition and activation of inflammatory pathways, again related to oxidative stress, as you can see in there as one of the key effectors, defective autophagy, possibly because of the activation of these nutrient sensing pathways that are actually leading to that kind of thing. Neural stress and neuroinflammation as well, all because of overnutrition, which we can see as well in the chart opposite as creating neural apoptosis, actually enhancing neural apoptosis. Metabolic syndrome has been actually an accumulation of abdominal fat has been related to brain disease. This is not new science, but this is an article again from Frontiers, if I'm not wrong, on neuroscience, linking visceral fat to cognitive impairment and dementia in this case. So it's looking at BMI and generation of adipokines, so a positive correlation between BMI and abdominal fat, even a couple of inches around the waist. So again, when we talk about obesity, we have the idea of somebody who's really large, and we don't need to be that kind of very large person. It can only be a few inches around the waist that are having that same kind of effect. So the moment that our blood pressure is actually raised by a few points, that you may have a few higher points in your blood sugar markers or your glycated hemoglobin. And again, if you've got that kind of accumulation of visceral fat, you're contributing to cognitive impairment. And again, the same kind of thing in here from another current paper on how chronic overeating or chronic exposure to too much energy, too many calories, actually alters the body's glucose homeostasis, and that has a permanent effect on what is called a negative plasticity on the brain. So it actually changes brain structures in a negative manner. So we've talked a lot about free radicals and how they are able to affect different organs in the body, different systems in the body, different tissues in the body. When you think about that, the brain is actually 60% fat. And fat is actually, depending on the type of fat, is very susceptible to damage, particularly when it's unsaturated fat. So if you look at the kind of fat that we've got in the brain, which is towards the end of that spectrum in there, so plenty of hydrogen and carbon bonds. So we've got the very long polyunsaturated fat molecules like the C24s and the C18s as part of the brain. So the polyunsaturated fatty acids. That the longer the molecule, the more susceptible to damage by free radicals. So if you think of free radicals as balls in a pinball machine, and you've got the tissues on the body being touched by the ball, being pinged by the ball, and every time that they are pinged by the ball, they're actually kind of like punching a little hole or kind of like damaging that tissue. When you think about fat, a molecule of fat that's actually very elongated and is very delicate is actually very susceptible to damage by those free radicals pinging about. So that's why free radicals and central nervous system are actually not a really good combination at all. So when you're talking about brain aging, we cannot go away from the need of free radicals because we need them for energy. So you don't want to be so asleep because you haven't got the energy to actually think and to maintain normal cognitive function. But at the same time, you don't want to be affected by an excessive amount of energy that generates an excess of free radicals that affect that fatty tissue, that 60% of your brain, that's fatty tissue, and that's going to turn into neuronal death at the end of the day. So it's actually going to kill your neurons, either little by little or lot by lot, depending on how much free radicals you've got going on. So a lot of what happens with free radicals in the brain is the fact that membranes of cell membranes are actually affected, and neuronal cell membranes are affected because they are really rich in fat as well. So this has a direct effect on the rate of aging or longevity. So the amount of free radicals that are actually generated in the body is directly correlated with the rate of aging and longevity. And whilst we need a little bit of stress to continue to evolve, If we have too much stress or too much oxidative stress, that can actually turn into oxidative damage and too early senescence or apoptosis or cell death. So we start to see, even though I said that I'm actually not going to talk about specific labels, we start to see a couple of different themes that are recurring themes, like the oxidative stress and the generation of inflammatory markers, as well as mitochondrial function that overlap with a couple of the big names, so the Alzheimer's and the Parkinson disease, for example. So that's a couple of the two main themes that are recurrent in all neurological diseases. One of them that also is recurrent is iron overload, and iron is actually a very interesting mineral because it's an oxidative mineral. So if you look at your garden chairs at the end of the winter when they've been out in the yard, they are rusty. That's iron, basically. That's the oxidation that iron is actually doing in your brain as well if you've got too much iron going on. It's the same kind of thing. And so basically we're always going to be somewhere along the line of this repair and damage spectrum. So at one end of the spectrum, we've got the ability to repair or to maintain the RNA, to ensure adequate protein turnover, to ensure the integrity of cell membranes and the regeneration of blood and epithelial cells. And on the other end, we've got the damage by free radicals. So we're never going to be at one end or another completely. We're always going to be floating about in the middle somewhere. And we're going to get into the practical application of how we go from one end to the next. So if we're too much towards the oxidative end, how do we turn to the non-oxidative end? And we do something about it. So the more kind of like practical stuff. Have you any questions so far? Have I bored you to death? Yeah.
Hold on. There you go.
All right, microphone.
How you doing? You're talking about the oxidative damage or the free radicals. I've heard some people discuss if you have too many antioxidants, maybe your body doesn't clear away what it should have. That would have originally been taken away because you're doing some repair and now you're leaving that cell. Do you have anything to say on that?
Yeah. And that's true. I would not advise on going on these mega dose antioxidant therapies that people talk about for a long time, because what you're doing is you're tampering with your body's homeostasis, with your body's antioxidant and oxidant status. Basically that equilibrium that you've got in there, you can actually go too much on the antioxidant end. As a short burst, if you're dealing with something specific, otherwise lower quantities and long term as opposed to high quantities long term. Yeah. And some antioxidants are actually very easy to, they've got a long life and they can actually recycle other antioxidants, like N-acetylcysteine, for example, is a good example. Alpha-lipoic acid, that's the same kind of thing. They kind of recycle other antioxidants, but at the same time, they're very safe at high doses. Whereas some other antioxidants, especially polyphenols, because we haven't got the science yet, in theory, they sound fantastic because they are kind of like the perfect example of how you can maintain the integrity of your DNA. But at the same time, they are hormetic substances. So they can actually have a sharp curve where they actually at its very maximum point of efficiency, and we don't really know enough yet to say this is where they start going nasty. So you could think that you're doing yourself a world of good by taking like 3 grams of resveratrol or something every day, and maybe for the first 3 days or the first week, your body is loving it and your brain is thinking, wow, this is amazing. and the next month you're actually enhancing cancer. So, and that's one of the things that they are talking about. Specific polyphenols administered as a one only, so a single polyphenols at high dose, they can actually enhance the pathways that you want to inhibit in the first place. So they can actually have a bounce back effect.
I understand also that there are oxidative molecules. In specific answer to that question, I understand also that in specific answer to that question, I understand that there are also oxidative molecules that are signaling molecules. And so if you have too great an antioxidant load, then the signaling molecules that are meant to be there are also short-circuited.
Yeah, true. And that's true with iron as well. So iron is a signaling molecule. It's a metal signaling molecule. The same thing with copper. So again, you want to have a little bit. You don't want to have too much. But if you inhibit them too much by providing too many antioxidants, then you're not doing yourself a favor.
Thank you. You talk about excess hormone causes aging. Which one is most damaging? Do you have like a list from? Yeah.
This guy, Lagosconi, I'll write it or I'll spell it in a second. It's quite a long name. He's written a lot about that. Main one is cortisol, testosterone, growth hormone, but also insulin growth-like factors, so IGF-1, for example. So those are the main ones that actually push into the MTOR pathway. So I think I had to a certain extent, yes, but I think testosterone is the one that's more damaging. Now, you know that females have DHEA as a proxy hormone or a pro-hormone. So, and that's actually a lot more long-lasting than estrogen because it actually works after the menopause. So, depending on how your DHEA levels are, you could actually be producing more estrogen after the menopause or more testosterone after the menopause, just directly from your adrenal glands. So if you're worried about that, then checking your DHEA sulfate levels in blood and making sure that they are kind of like in the middle towards the low end, middle to low, as opposed to middle to high, and definitely not taking the huge amounts of DHEA that I'm surprised is available in the supermarkets here. It's banned in the UK. You need to go to a physician and get a prescription, and they look at you funny as well because it's like a steroid hormone. Why you want to take a steroid hormone? And you can buy it in Walgreens here, like 100 milligrams. Wow. That's kind of crazy.
Question. My understanding from all my reading is that our ancient ancestors had very little glucose in their diet. They're basically protein eaters, and that's what they existed on. And, you know, the idea that we have all these fruits and vegetables was not the antithesis of really what they had when they were roaming the plains.
Yeah, you're right. And I think that's why I was saying that this is one of the kind of rhetorical questions I had in the beginning. Do we have the same genes as we had 20,000 years ago? I think we have practically the same genes, but we live in a sci-fi kind of world where it's all kind of like plastic and dusty around us, and the berries are in the supermarket, but we're not picking them up. And then we've got all this candy and cakes that we can just grab anytime. And, you know, our DNA is actually programmed to be challenged by this kind of feast and famine kind of balance. So I think that's why caloric restriction actually is one of the best proven interventions in most species actually, and in humans there's ethical issues with starving somebody for a whole week to check whether blood biochemistry is changing, but aside from that, if you try at home not to eat for a few days, you probably feel much better. Or to cut down your calories by 30%.
Yeah. Got a question. Is it on? On? Yeah. I worked with Roy Wolford at UCLA in caloric restriction diet. And one of the things we did was we looked at other parameters that were the same as caloric restriction diets. And one of the things we found is that by restricting certain things like testosterone and also amino acids like leucine and methionine.
Branched amino acids.
Yes, and methionine, you get the same results as caloric restriction diet. And then the newest thing I got into...
That's what you see in there. So
yeah.
That's actually pushing into the same
right.
weather station, that's MTOR, that's picking up the signals from amino acids, particularly branched amino acids,
right.
as well as glucose and testosterone.
Yeah, so you want to limit that in your diet. And also, the other thing, and this is exciting because mTOR and IGF-1 is like the key factor, that if you raise NAD levels, the oxidative state of the mitochondria, when it's in a low level, it forms IGF and mTOR. It elevates them, and that's what is increased. So even by looking at NAD now, that's where all the science is exciting and handling all these pathways, because you are talking about all the aging pathway, which is exciting.
Thank you. Any more?
In your opinion, is the free radical theory of aging the most important aspect of aging as opposed to the other SENS mechanisms like advanced glycation end products, for example, or telomere length, or cellular senescence?
Yeah, I don't think there's one that actually explains. There wouldn't be just the one that explains everything perfectly. In the sense of the central nervous system, because of its amount of fat and because it's highly polyunsaturated fat, then it's more sensitive to free radicals, but it's also sensitive to oxidation from homocysteine, for example, that can self-oxidate, and is also sensitive to glycation products like just your glycated hemoglobin that you can test very cheaply, that is going to have an impact on, again, the same kind of free radical impact on fat, on lipids. So there's not one theory actually explains everything perfectly. I think the one that I embrace as the most kind of all-encompassing is this nutrient sensing pathways, just because it makes more sense from an evolutionary perspective as well.
Where do you think that deprenyl's, at least in animal models, life-extending mechanisms fit into all this? Deprenyl, salicyline is the, but it's an MAOB inhibitor. Are you
I don't know it.
Okay.
Yeah, I'm not familiar with that.
If you're looking at things that have mTOR inhibiting pathways and GSK, look at it, lithium. Low-dose lithium causes neuron and neurogenesis, and also suppresses inflammatory mechanism in the brain, and it's now shown to grow a new neurons in the brain. So I would look at low-dose lithium orotate.
What is low-dose?
No more than 15 milligrams
15
a day.
milligrams, yeah.
Yeah.
There's lithium, is it lithium aspartate as well?
No, orotate is safer than aspartate because aspartate has an excitatory mechanism.
Right, yeah. Okay.
Do you want to continue on with
Yeah,
Okay.
I do. I'm just going, oh, hang on, what have I done? Have I lost it? Are you going to type a fancy code again and retrieve it?
Let me try.
Okay. All right, there we go. Oh, Okay, cool.
Let's see if this will.
I just.
No.
Okay, I'm just gonna have to go down really quickly through. Okay, any other questions while I scroll through? We haven't.
Hold on.
I would have a question about the overnutrition. Does it matter what kind of overnutrition from, like the spectrum from the SAD diet, standard American diet, versus completely raw diet, for example?
Yeah, I know where you're coming from. Most of the studies are actually done on either standard American diet or similar Western diets. But you can have a very unhealthy vegan. I was a vegan for 7 years, and I hung around with all vegans. I was trained to be a yoga teacher, and some, and it was all rice cakes and kind of, and nice things. But some of my friends were appalling eaters, really, really bad eaters, and they just thought because they were vegans, they were like cool, but they ate real crap. So it doesn't mean that, you can overeat, and you can have a really high glycemic load diet as a vegan. It's actually very easy if you eat grains. So that's to start. So if you have a grain-based diet, you can have a really high amount of sugar going in, even if it's ancient grains and quinoa and things like that. You can overload your sugar mechanism. High fat is good. But then again, I think it can be a bit faddish as well. There's a lot of contradictions. So, but the models on Alzheimer's, for example, and Parkinson's with things like medium-chain triglycerides and from coconut are very promising. I actually feel really good on coconut. I can eat loads of coconut fat and butter more than things like olive oil, for example. But then again, it depends on your genes and whether you've got a favorable or unfavorable ApoA1, for example, gene that allows you to metabolize polyunsaturated fatty acids better or worse. So if you've got an unfavorable variation and you think you're being very healthy by eating loads of olive oil, and you're not able to break it down, or taking fish oils, or taking, fancy omega formulations that are hundreds of dollars with omega-3, 6, and 9 or whatever, if you cannot break the bonds because you haven't got the enzymes to break them, then you're going to feel funny. It's not going to make you feel as optimum as you could feel with other fats that you can easily break down. Like medium-chain triglycerides are actually very easily to assimilate because they bypass the bile metabolism.
Yeah, well, I mean, with what you were saying with hormones, so there's been quite a big trend in all the bioidentical hormone therapy. But I mean, am I understanding from what you're saying, even with if they're taking it within those ranges, you're probably really recommending long term that shouldn't be doing that?
Yeah, I'm not against bioidentical hormones, but if somebody's going to take them, I would go for low dose and titrate up, as opposed to go for the shocker and then kind of think, oh my God, I'm having palpitations or something, and then go down. So tiny, tiny amounts. So I know some people are doing really well on 5 milligrams of sublingual DHEA. And I know some doctors that the first kind of prescription would be 25 milligrams. So it's 5 times as much. Pregnenolone can be pregnenolone being at the top of the steroid hormone chain. Even like 2 milligrams can be very effective if you've got fatigue issues. But some doctors are actually giving you 10, 20, 25 milligrams to start with. So people get palpitations, they get sweats, they get all sorts of things going on. So you're really feeding into these nutrient sensing pathways, hormone sensing pathways. They are sensing pathways of abundance. So if there is an abundance of anything in your body that's going to make you grow, that's what they pick up on, whatever it is, whether it's a hormone, a sugar, amino acid, whatever it is. So if you go slow, then you're going to engage them less, and that lesser engagement actually generates less revving up of the system.
So I mean, the nutrition sugar side is the same as the hormone side because it all leads to growth, and growth leads to aging.
Yeah, and that's why I think in the way I practice, I would not give people mega doses of nutrients willy-nilly. I would try and give them a sustained dose that makes sense, as opposed to these mega dosages that could be really good if you, I don't know, if you have intense inflammation because you have just reacted to something and you want to dampen it down, and you take 1 gram of quercetin or something for a week, but then you go down to taking 100 milligrams a day. So
Got you.
we just don't know. We don't know. I haven't finished. But thanks. Okay, thank you.
Isn't that the holy grail, though? If we knew exactly how much nutrients our bodies need on every various level, then all of us would live to 300. So.
There's a lot of fats on just the kind of a high dose, and I think particularly on the polyphenols, it can be a bit dangerous to do it on a regular basis.
Is the body geared to be hunting as opposed to being satisfied all the time? So when you eat 3 meals a day and you're always satiated, isn't that contrary to what the body is really geared for historically?
Yeah. Yeah, it is. And there's a lot of science supporting that. There's a few of the studies I'm going to show you in a second, actually. There's this Canadian doctor, PhD in nutrition, called Krista Varadi. She's done a lot of research in what she calls alternative day fasting, which is basically just cutting down calories a couple of days a week. It could be a couple of days, it could be every day if you want it, but she does it a couple of days a week only, or 3 days a week. And the results on metabolic markers are incredible, really good within a short space of time. So you can actually, and that's a confirmation from nature saying this is what you should be doing. Right, shall we move on? Cool. So caloric restriction. A lot of the stuff that we've been talking about is eating less, or eating not less, but more nutritious foods that are less calorie intense. So the markers associated with cardiovascular disease and neurodegenerative diseases are actually improved quite remarkably. This is rhesus monkey that's been fed, the one on the A and B, that's been fed a regular full 100% calories diet. They normally live until about 25, 27 years of age. So that's 15 years of caloric restriction, as opposed to, so the one that looks younger, same age, 1 caloric restriction, the other one no caloric restriction, nothing else, no supplements, nothing else, basically just 30% less calories than the other one. And you can see the pigmentation in the hair, everything is just like a young monkey. And we're not that far from monkeys, really, so some more than others, but in general. Pardon? 30% in calories, yeah. So that's dietary restriction in there. We've seen those in there as well. One of the mechanisms, indirect mechanisms for caloric restriction, is the enhancement of this set of genes called sirtuins, and particularly sirtuin 1, which is a bit of a trendy gene because of the resveratrol kind of saga. So resveratrol has actually been proven not to be very effective when it's administered as a single polyphenol on its own, even if you take lots of it. It's actually working much better when you take it with other polyphenols like quercetin, for example, and the sirtuins are connected to a number of different tissues in the body. They regulate apoptosis in a number of different tissues, so cell death or programmed cell death. They also regulate things like vascular tone, which is really important in the brain, and neuronal differentiation. So when you are resistant to neuroregeneration or neurodegeneration, to both, that can actually be modulated by sirtuin genes. And the interesting thing is that sirtuins actually put a brake on MTOR as well. So they are almost the alter ego of MTOR. So when you enhance sirtuin activity, you're actually putting a brake on MTOR activity. So that's why resveratrol has got that the ability to do that the same as rapamycin to a certain extent, again, because it's a hormetic substance. So we don't really know what the cutoff point is just yet. So dietary restriction, that's probably enough on that. Alternate day fasting. This is the lady I was telling you about. So her name is Krista Varady, V-A-R-A-D-Y, V for Victor, A-R-A-D-Y. And she's got about 20 different papers on journals like Nutrition Journal, Metabolism, High Impact Factor journals, talking about the same kind of thing, combining alternate day fasting with exercise, without exercise, doing the fasting on the exercise day, doing the fasting on the non-exercise day, all these kind of funky combinations of caloric restriction with the name of alternate day fasting, the same kind of thing with a different name, and the results are all really quite something. So caloric restriction, again, it enhances the function of sirtuin-1 genes. It also enhances the activity of telomerase reverse transcriptase. So telomeres, again, when we're talking about aging, they've been named a bit like the Holy Grail. Everybody's talking about telomere length as the answer to everything. I don't know that they are the answer to everything, but they definitely give us a marker on how rapidly you are aging as a result of different exposures to stress, for example, psychosocial stress and telomere length. There's a lot of studies on that are really interesting. So the earlier the exposure to stress, even in utero, so even a stressed baby by means of a stressed mother. So basically, if a pregnant mother is really stressed, the telomeres in the baby, even 20 years later, are actually shorter just from that exposure. And in rats, actually, this goes up to 3 generations. So exposure to stress during pregnancy actually transfers into up to 3 generations of downregulation of telomere reverse transcriptase. So, and brain function as well. So MTOR inhibition and metabolic syndrome. So as you can imagine, if we're talking about metabolic syndrome, which is the typical kind of disease or illness that's related to excessive calorie intake, that is going to be related to MTOR as a nutrient sensing pathway by generation of excessive fat around the middle, so visceral fat. That's going to have an impact on cardiovascular disease, metabolic imbalances that lead to hyperglycemia and hyperinsulinemia that have a direct impact on brain function and cognitive function. So if you don't want to stop eating so much, or if you don't want to give up the cheesecake, Susan's made a lovely cheesecake, by the way, right at the front, or the turkey. Thank you, Sharon, for the turkey. That was really tasty too. So if you don't want to give it up, or if you want to enhance the effect of fasting that you may be doing, or the effect of calorie restriction that you may be doing, a number of different substances have got these properties that are calorie restriction mimetics, so they mimic the activity of calorie restriction. So in my experience in clinic, if you fast or if you restrict calories and you take any of these substances or a combination of these substances, you actually get much better results than if you just continue to eat the candy and the cakes, but then you take some of these CRMs. So just combining the two is actually better. And resveratrol, I was actually kind of slagging off resveratrol before, just saying that it doesn't work. It actually does work, and it's very effective at working at what it does. It's just that it has had a lot of press on doing all sorts of things that when you look at the studies in detail and you look at the amount of science that's behind, at least 100 milligrams. Yeah, when you look at supplementation as a single agent as opposed to supplementation with other agents, is the supplementation together with other agents is actually much more effective as a single polyphenol. So my recommendation would be 100 milligrams daily, alone or in combination with other substances, particularly quercetin. There are some really good studies on resveratrol and quercetin. And again, the reason why I like resveratrol is because of that activity on the, I keep getting confused, on the sirtuin 1 gene that puts a direct brake on MTOR. So it kind of like silences the nutrients around MTOR. And it enhances autophagy or correct autophagy. Resveratrol also helps to indirectly, so it's not directly on the brain, but it actually helps modulate levels of leptin and glycated hemoglobin in the blood. Both substances actually travel through the blood-brain barrier. Leptin concentrations actually increase with resveratrol, so it actually allows you to modulate the appetite levels, so it can also be seen as a kind of appetite suppressant indirectly, so it's not going to suddenly make you not want to eat, but it has that kind of subtle effect on the brain. And glycated hemoglobin is one of the advanced glycation end products that is very oxidative, travels through the blood-brain barrier and can directly affect fat tissue in the brain. So it can enhance oxidation in brain tissue. So it's not a good idea to have high glycation levels if you're looking to enhance your cognition or to have a clear mind. You need to be looking at those as part of your labs. So again, we were talking about key calorie restriction mimetics, and quercetin normally comes from onions, but apple skin and supplements are other sources. I would go for supplements because you would need to eat a lot of onions or a lot of apples to get 100 milligrams of quercetin. And some studies that I found, and I believe they are quoted in the notes section there, talking about combination with resveratrol to improve cardiovascular markers. So it downregulates NF-kappa B expression, so the main inflammatory initiator of inflammation cascade in the body. 100 to 200 milligrams daily is a safe dose in my view. Again, maybe I'm too conservative, but I'd rather have that on a regular basis than to have higher amounts unless it's a short spell or hay fever season. Some people actually react very well to quercetin. It does nothing for me in that aspect. So I can take lots of quercetin and vitamin C, and some people say, I stop sneezing, I feel great. It doesn't do anything for me. So I think it must be something genetic as well. You either, it either does that or it doesn't do that for you, but there's no question that it actually dampens down inflammation at low levels. A lot of the calorie restriction mimetics, that's supposed to be CRM, not CMRs. in there, sorry, are actually seen in this study that I found, thought it was quite cute, calling the Mediterranean diet. And it actually is, it looks at an overlap of nutrients between the Mediterranean diet and the Asian diet. You talk about the Mediterranean diet here? Yes. Yeah, because in the UK now suddenly it's like the holy grail, and now Public Health England is talking about the Mediterranean diet as the answer to all health questions. And me being Spanish and having grown in Spain until I was 20, and my mom and dad are from the south, and we have loads of olive oil and garlic and onions, and you know, it's kind of like a Sicilian family. So I'm used to the Mediterranean diet, and I find it quite hilarious that now it's kind of trendy in the UK, which is not very Mediterranean. But we'll see some of the stuff we've been talking about, or we'll talk about, like the curcumin, soy isoflavones. I'm in two minds about those because of the potentially GMO origin of soy, but definitely green tea and seaweed and red wine. I'm not sure whether this is true or not, but somebody at school years ago when I was training said that you had to drink 100 liters of wine to get 100 milligrams of resveratrol, which sounded like a really good idea, but not if you've got work to do the following day, and not on a regular basis. So a lot of what we've been kind of like hovering over is genomic stability and the integrity of DNA. And a lot of these compounds that we've talked about and that we're going to cover in the following few slides are actually able to interact with the epigenome, with our genes via environmental dialogue, and interact at levels that actually elicit changes in chromatin fibers, for example. So they can actually repair the integrity of DNA. We can see that we've got phytochemicals, polyphenols coming up at different stages of this degradation, from the initial exposure to the actual modulation of physiological function. So basically, this is the initial exposure to either stress or diet or environment, chemicals, drugs, whatever. That's kind of like a shock to the system. And that's at the bottom, the actual modulation of the physical function. So the illness, we could say, as a result. And at very many different stages, we can actually activate processes that are protective processes by means of the use of different polyphenols. If you're looking to understand a little bit more about genomic stability or genomic instability, Bruce Ames, you know Bruce Ames? All right, cool. So that's his bag. That's basically, he may have actually even coined the term of genomic instability. He's been talking about it for the last 30 years. But he's a really cute professor as well, with like bow tie and everything. So it's kind of really good to watch. And that's a really good video as well, only half an hour. Now, knowing your genes actually helps, because if you're going to be supplementing any of these substances willy-nilly, you might as well know whether you can take more, or whether you need more, or whether your body will tolerate more. So you've got your genes. This is a panel that I run in clinic on a regular basis. It covers a lot many genes, but this is these are just a few of them: detoxification and antioxidizing capacity based on superoxide dismutase, glutathione transferase, M1 and T1. So we've got 2 glutathione genes in the body. You can either have both of them, you can have none, or you can have one, and or either of them. And with the superoxide dismutase, you actually have got a whole bunch of them. But the one that's a lot of the studies actually measure is the SOD2. So different locations, but the SOD2 in different variations. That's the main one, the main variant that is measured in different studies. Now, if you've got an unfavorable genotype, so that means that you're not very well gifted in terms of protecting yourself with your own antioxidants that you generate internally. you are justified in taking higher dose antioxidants that are protecting you externally via your diet or via supplements, because you're not going to be tipping yourself over onto a highly antioxidant end of that spectrum between oxidation and antioxidation. So if you had all the favorable variations, both glutathione genes present in green and a green in there as well, and you're overloading yourself with antioxidants, that probably I wouldn't recommend you that as a clinician. Sorry. There was a question there? No? So that's one way of actually judging whether you need those antioxidants in higher dosages or not. Knowing some other of your genes like vitamin D receptors, so that's another couple of genes that I normally measure as well. So 2 receptor genes, VSM and TAQ. If you've got an unfavorable variation on those, it's normally going to mean that vitamin D receptors are either in fewer quantities on the cell membrane, or they are actually likely to be under-functioning. So you're better off taking higher dosages of vitamin D, which is, again, another cognitive enhancer. So that's always good to know if you've got the ability to do that via your clinician. So dietary phytochemicals we've talked about, they do this thing that's really cool, which is either promote acetylation or deacetylation or methylation. So methylation is the silencing of genes. Acetylation is the opening up of the plastic cable that surrounds DNA matter. So you're letting the information out to the environment. So either protecting and closing down the gene, or actually enhancing protein expression. And a lot of these different substances, like the resveratrol, sulforaphane, curcumin, watercress, broccoli, somebody was talking about broccoli before, have got the ability to do that. Garlic as well, never underestimate garlic. And that's another whole list of them in there as well. And I've mentioned a couple of times hormesis. So hormesis is the term that describes how some substances have this curve that doesn't correlate with more is better. So more is better up to one point, and then after that point, actually more is actually worse. So this is what I was saying about polyphenols particularly. So I'm a great advocate on polyphenols. I think having a diet that's really rich in colors and that you eat a rainbow of different colors every day is a fantastic tool to keep your health as optimal as possible. But if you're playing with extracts, which are in a way refined pharmaceutical grade extracts of these substances that you can get in the supermarket, that's almost like, you know, playing with fire in a way. We've got a lot of science that's based on animal models, a lot of science that's based on models of the brain, on models of different tissues, not so much science on humans. As similar as we may be to a rat or to a monkey, to have a study that's actually done in a human actually gives you some reassurance that that thing is going to do what the study in a rat said that it would do, and not just guess that it would do the same thing, because we're not exactly like a rat or like a monkey. So we're likely to react to that dose stimulation ratio at a different point, and whilst a rat or a monkey may take 500 milligrams of resveratrol quite easily daily and not think about it twice, you may actually react differently. So a lot of these substances are actually generated by plants as a means of protection. So they're actually generated as natural insecticides to stop insects from eating them, or to stop birds from digesting the fibers. And if it's a seed, for example, its ability to come out the other end and actually grow into another plant. So you need to think about that thing as well, that they're not just like gifts of nature that are just wonderful. The plant may have actually developed them as a toxin to start with. So and once you get the slides, you'll see this study is actually a bit of a gem because it's got all of the properties of all these plant phenolics summarized in one really cool study, talking about all the polyphenols that we've been talking about and even more. So gingerol from ginger, resveratrol, we've talked about hundreds of times, quercetin, caffeic acid, quite a few of those in there. And the benefits are along the same lines that we've been talking about. So stimulation of the sirtuin-1 gene that is going to be a protector of healthy aging or successful aging, enhancing of nitric oxide synthase, so vasodilation in the cardiovascular system, anti-inflammatory in general, lowering LDL. They also are really cool because they are some of the few substances that they can travel through the blood-brain barrier. So a lot of these polyphenols, either the whole molecule or tiny bits of the molecule that's broken down by stomach acid and amylase in the small intestine, actually can travel to the brain. So that's actually quite remarkable because not that many substances can actually make it to the brain. More on how to enhance genomic stability, caffeic acid, so coffee. I love coffee. I love the buzz that it gives me. But at the same time, I also like to think that it's keeping me young. So that's actually doing that via two means: caffeic acid, which is not the same as caffeine, but also chlorogenic acid. So that's chlorogenic acid. You're better off taking it as a supplement because you need to drink a lot of coffee to get that amount of chlorogenic acid. You need to be in Starbucks every hour of the day. Pine bark extract is possibly one of my favorite ever nutrients. If I had to choose, you know, like those programs that they say choose one person and go to a desert island with them. If I had to choose one supplement, I would choose pine bark extract and go to the desert island and sunbathe because that'd be cool. Yeah, pycnogenol is the trademark. And then if you've got a guaranteed 95% proanthocyanidin extract, that's not got the trademark, it's probably going to be a fraction of the price, but still do the same thing. Yeah, so a 95, when you see on the supplement 95% OPC, it basically means that it's guaranteed to do the same thing as the trademark, only you're not paying for the trademark. So it's very safe to take in huge dosages. And if you're worried about your skin and the kind of anti-aging of the skin as well as the brain aging and many other things, this is the anti-wrinkle miracle. Like, you know, people say, oh, this is the anti-wrinkle miracle. Well, this is the anti-wrinkle miracle. This that actually does amazing things to the skin. But also, pine bark extract is really good for cognition. It balances blood sugar levels. It decreases glycated hemoglobin. It dampens down inflammation. It makes your skin depigmentate if it's actually photo damage. You know, like kind of like freckly little bits and liver spots. They actually fade away with pycnogenol or pine bark extract. This is 6 months on 30 milligrams, which is nothing. So pine bark extract, as I said, it does a whole bunch of things. Like oxygen-free radical and hydroxyl radical, as well as the superoxide radical. So it's really good affinity with the brain because there's a lot of hydroxyl radical activity in the brain. Really good with melatonin. So taking it at night with melatonin enhances hydroxyl radical protection. Beta melon is the one that you were talking about before. Now, there are hundreds of different varieties of beta melon. Talking about beta melon is a bit like talking about apples. You've got Gala and Pink and Fuji and you name it. So basically, beta melon works wonders for people who have got blood sugar dysregulation, and they also have really high oxidation. some of the drugs for blood sugar regulation actually work via the mitochondria, so they actually enhance free radical production as a side effect, whereas beta melon actually doesn't. So it actually doesn't go via the same pathway. So it's actually a really cool kind of in India they actually call it vegetable metformin. So when you go to an Ayurvedic doctor in India, they actually tell you that that's vegetable metformin, it's your vegetable diabetes drug. It's also highly antioxidant. You don't want to take it if you're looking to conceive or if you're giving advice to somebody looking to have babies, because it can actually damage the fetus, and it can, at really high dosages, it can actually provoke a miscarriage. So not a good idea if you're looking to have babies, but if you're looking to do anything else with it, a good idea. It's extremely beta if you juice it, like absolutely the most beta thing you can ever taste. So if you think that you're doing this wonderful green juice, I've got about 3 minutes left, is that okay? Really beta green juice is not a good idea, it's too beta. I was just looking at relationship. We talk about a lot about the gut-brain axis, and gut-brain is kind of like trendy topic. Gut-brain and liver-brain is kind of really trendy as well, because liver-brain will be the next gut-brain. These things go in trends. I think I'm expecting the next trend to be liver-brain. And you look at some of the compounds that we've been talking about, and they're all related to antioxidant protection of the liver tissue. If you want to maintain cognition and good brain health, maintaining your detoxification pathways, the actual metabolic pathways in the liver intact or as integral as possible is paramount. Astaxanthin is a really cool, I cannot pronounce it properly, it's very difficult for me to actually say it, but it's a really cool antioxidant in that it's got a molecular structure that allows it to penetrate the bilayer in the cell membrane, so it goes through the fat and it goes through the water in cell membranes. So it's kind of a fine with phospholipids from a molecular point of view. So it actually penetrates through the whole of the cell membrane. Again, another really good antioxidant for brain because of the fat content of the brain, but also because of the water content of the brain. So it's 30% water, 60% fat. So this is the ideal brain antioxidant and really good for skin as well. 1 to 4 milligrams daily. If you're concerned about the origins, it tends to come from krill. So krill can be overfished. If you've got a bit of an environmental conscience and you don't want to kill things and you're sorry about krill, then you can take the vegetarian one that comes from algae or red yeast as well, although it's not very bioavailable. But the one from seaweed is actually pretty cool. And it's actually got a really good correlation with diminution of beta amyloid plaque in Alzheimer's disease. So that's 12 weeks after administration of 4 milligrams of astaxanthin. No, 12 milligrams, sorry. Other carotenoids, lutein has got a really good rap, not only for eye, but also for brain tissue. So 2 to 10 milligrams. It's actually part of a medical protocol for macular degeneration. And it's being used in China as part of a protocol for macular degeneration with melatonin as well. 3 milligrams of melatonin and lutein as part of that protocol. Lutein can actually be obtained from foods, like real easy, like from avocado, for example, spinach, but you can also take it from supplements. Green coffee is another one of my favorites as well. It actually enhances the production of brain-derived neurotrophic factor, which is one of the substances produced in the brain when you fast. So when you're not actually eating, you produce this BDNF. Folate and vitamin B12 because of their ability to tackle homocysteine that can self-oxidate. And homocysteine actually is related to the development of Alzheimer's disease. So again, if you know your genes, this is from 23andMe, and if you know that you've got an E4, E4, ApoE4, ApoE3 kind of variation, then you're better off taking a good folate supplement and a good B12 supplement in an absorbable way, like L-methylfolate, for example, which is bypassing all of the regular metabolism of folic acid. Beta melon we talked about before as well. Melatonin we've talked about. Melatonin, this is a study from last month on melatonin enhancing all of the things that we've talked about. So inhibiting MTOR, enhancing autophagy, promoting sirtuin and transcription factors like the FOXOs for longevity. So talking to your genes via the environment. Aside from resetting the circadian rhythms, it's also having a calorie restriction mimetic effect. So it's actually coming up as a really trendy, you know, the old-fashioned melatonin is coming back up as a really trendy, reinvented kind of nutrient for longevity. And it fits into the glutathione cycle in there. So as we looked at before. Cocoa, raw cocoa, is a really good antioxidant for the brain. It diminishes the risk of stroke. Coffee does the same. Tea does the same. Vitamin D in relation to cognitive impairment and brain volume. So the higher the vitamin D levels in blood, vitamin D3, the higher the brain volume as we age. So curcumin has a whole lot of properties as we've seen there. These are all the genes that are activated by 1 single teaspoon of curcumin. Inflammation genes, antioxidant genes, apoptosis, cell proliferation, and mindfulness. And this is what I was talking about before. When you self-regulate, mindfulness sounds kind of a bit woo-woo, but it's not. There's a lot of science behind how if you self-regulate, you're managing the two sides of the central nervous system, the sympathetic and parasympathetic side of the central nervous system. And that actually takes you from a place where you're generating depleting emotions and enhancing cortisol levels that we saw as one of the culprits in pushing the MTOR pathway to a more regenerative place on DHEA production and lower heart rate, lower kind of a metabolic rate that's conducive to aging. So thank you for your time and your patience today.
Okay, we have to be out of here by 10 o'clock. So, yeah. Yeah. Yeah, I want to take a couple of minutes here and see if there's another question or two to kind of wrap things up, but I would definitely want to cut everything off by about 9:45. So, are there any?
I'll send them to Susan, so you'll have them later today.
Any other questions?
Yeah.
Okay, hold on.
My question is, time of day fasting, is it good to skip breakfast?
That's the best in my opinion, because you're lengthening the time between two meals in the most natural way, which is by basically leaving a longer time between dinner and lunch the following day. Yeah, so if you can manage to do that, that's the best way of doing it.
Okay, thank you.
Even doing just one meal a day every week. So if you can manage to just one day a week, just have the one meal a day, even if it's quite a big meal. There's been an article published in Cell Metabolism on rats that were given a very short span of time span for eating during the day, and they were allowed to eat as much as they wanted. So they were having like the equivalent of like 5,000 human calories, but concentrated in 2 hours of the day, and they don't put on weight, and the metabolic markers are actually fine. So your body is almost prepared to eat lots if you concentrate it in a small section of the day, as opposed to just eat lots all of the time.
Yes, pine bark. Is it better if you breathe it through a nebulizer, if you take it orally? Pycnogenol.
I don't know about nebulizing it.
Pine bark, pycnogenol. Okay.
No, I think you need to take it. Ideally, with these things, I like to think that taking them with fat, like coconut oil or olive oil, actually makes them work better.
Is supplemented glutathione metabolized, or is any absorbed intact?
My opinion on glutathione is that I prefer to support the promoting factors like N-acetylcysteine and vitamin C, as opposed to actually supplementing it.
Okay, brain fog, is that something has some nutritional roots, or what do you think about, the phenomenon of brain fog?
Yeah, brain fog, I would check your folate, B12, and folate levels on red blood cell membrane. Okay. So normally they are called active B12 and folate. It's a lab that you can order from your doctor, and that gives you an indication as to whether you need to supplement. They tend to work really well. If you're slightly deficient and you supplement those through, they tend to work really well at lifting that brain fog.
For calorie restriction, on a calorie restriction day, what's the minimum amount of calories and as far as the max?
Okay, so on a caloric restriction regime, I would normally recommend 800 calories as a low, yeah, a couple of days a week.
But then on the high, what's the other end of the spectrum?
Okay, so no higher than probably 1800 to 2000, yeah, yeah. If you're doing a couple of days a week of 800, that would balance out. Yeah, it's mild, but it's sustainable.
Okay, thank everybody for coming, and thank you, Miguel. Great talk tonight. Let's give Miguel a hand.
Thank you. Thanks very much.